Number 3 for college geometry. Welcome one, welcome all. Today, as you can see in front of you, we are going to be discussing perimeter, area, and eventually volume. Volume we're not going to cover until class 4. If you had a chance to look at the chapter, if you have a chance to look at the book. Really, today what we're going to discuss is perimeter and area. Next time we're then going to discuss some special area and special perimeter rules that apply to triangles, and especially right triangles, the Pythagorean theorem, and then we're going to segue over to volume. So by the time we finish chapter 3, which will cover 3 and 4, we will be discussing how to measure the space that a particular polygon takes up. Before we do that, I want to discuss a little bit about what perimeter means and what area means and what volume means. Perimeter means the area, or the amount of space, excuse me, not the area, the amount of the length it takes to circle the entire polygon, to go all the way around throughout the whole polygon. For example, if it's a square, it's to walk around all 4 edges. If it's a circle, it's to circle around the entire thing. We've all walked or driven or traveled around the perimeter of something in the past. Is there a lake that's near your house that you like to jog around, or is there a fountain that you like to walk around, or is there some kind of a town square that you walk around or drive around? What you're really doing is you're traveling throughout the entire perimeter of the object. Now, figuring out the perimeter of the object is especially important when you're planning the most efficient route for things. Anybody here take ideas in math by any chance? Way back in February, I guess I think it's given. If you've taken ideas in math, or if you will take it, there's something called an Euler circuit, EULER circuit, and really what that is, which is important in city planning, it's the way to figure out what the shortest route to hit all points is. In the old days they used to have the milk truck, and then today they still have, I guess, the cleaners or the bread truck or whatever it is. There may be 28 different points in a city that this milk truck has to hit, or this commodities truck has to hit, and there is a way. How do you figure out where the method by which you can hit all these points in a particular area? Now, if those points all happen to be around the edge of the same polygon, then that, of course, is a perimeter, and that's a simple perimeter problem. Otherwise, it may be a little more complex. How is the sound, by the way? I'm hoping it's all right. If it's everybody, then it's obviously my issue. If it's just you, then it's just your issue. How's everybody else's sound? Okay, good. All right, so I guess it's just a user issue. Okay, so again, very often it could be the connection. It could be just something that pops up that's uncontrollable. All right, so that's the perimeter. Okay, good. So then you have area. Area is a 2-dimensional thing. Area is how much ground something covers. And volume is something that's 3-dimensional, which is how much space something covers in all 3 dimensions. You could have a square and you ask about the perimeter of the square, is how long is it if you walk all the way or drive all the way around the square. You could have the area of a square, how much ground does it cover. Or you could have 3-dimensional in terms of cubic feet. We discussed this last time. You measure this by feet or meters or whatever. Square feet and 3 dimensions in cubic feet. Okay, so that's really what class 3 and class 4 is going to be about. So perimeter means the distances that are covered by all of the edges. For a triangle, well, figuring out the perimeter is actually very easy. Figuring out the perimeter of a triangle, simply add all the sides. That's really the only way. There's no trick to it. If this is 5 feet long, and that's 7 feet long, and that's 12 feet long, well, can anybody tell me the perimeter of this entire triangle? This is an extremely easy one. Just add them all up. 5 plus 7 plus 10, which of course is 22. So with a triangle, there's really no trick to it. With a parallelogram, there is a little bit of a trick to it. With any kind of a parallelogram, or even a rectangle, which is really just a type of parallelogram, the perimeter of a parallelogram or a rectangle is 2 times the length plus 2 times the width. And if you think about this logically, the reason is, let's say you have a rectangle, which is, the same thing applies when you're talking about a parallelogram. Well, this side is equal to that side. and this side is equal to that side. So whatever this is, if this happens to be 10 miles and this happens to be 5 miles, well, then this side has to also be 10, and this side has to also be 5. So it's 2 times the length, which is 2 times 10, plus 2 times the width, which is 2 times 5, and your overall answer is, of course, 30. Now, this formula becomes important. It may look like you may take one look at it and say, "Well, that's easy. Just add them up. Do the same thing." Well, it becomes a little bit more complex when you're told something like this. Let's say you're told you have a rectangle, and you are told that the length is twice the width and the perimeter is, let's say, 120 feet. And then you're asked, let's say, to find the length. That's a very common area. That's a very common type of problem. When you're asked either to find the area or asked to find the perimeter, you can do either one. Let's say we are asked to find the perimeter. So how would we go about doing this? And here's where we're going to start using algebra to accomplish our objectives. How should we go about doing something like this? We're told that the length is twice the width, and we're told the perimeter is 120. Well, the first thing we want to do is draw a diagram, and I drew a little rectangle over here. And what I'd like to do, you really only need one equation. And in fact, if you do 2 equations, it won't work because you need one equation to figure out what the variable is. But let's try to represent the sides in terms of a variable. What is the relationship between the variable here? It says the length is twice the width. So how about if we called the width, let's say x, and again, it could be y, or it could be a, or it could be z, but let's say x. If the width is x, what would the length be? 2x, right? You see why that works? Well, the length is twice as the width. That means we're representing the length as 2x and the width as 1x because that's twice as much as the first. Now, of course, I also could have said that the length is x and the width is a half x. You see why I could have done that? It's the same exact expression. Except it's a little easier to deal with whole numbers than it is to deal with fractions. Now, how about we apply the formula? What was the formula for a perimeter of a rectangle? Perimeter of a rectangle was 2L plus 2W. So let's apply this. I think it's really one equation, but okay, I think it's just semantics. All right, so our P was 120. So we're going to say P is 120 because we were told that the perimeter is 120. 2 times the length is 2 times 2x, which of course is 4x, plus 2 times the width, which is 2 times 1x, which is 2x. And now we could simply solve this like we would any other algebraic equation. How do we do this? For those of you who took algebra or know a little bit about algebra, hopefully everybody does a little bit. Well, you can do 120, combine the x terms because they're on the same side. 4x plus 2x is 6x. Now we want to isolate x, and we isolate x by dividing by 6. This is 6 times x, and whatever you do to one side, you could do to the other. So 120 divided by 6, 20 equals x. So, what does that mean? What is 20? Well, x is 20, but what does that mean in terms of the diagram? Well, we had defined them exactly. We had defined the sides as x and 2x. So x being 20 means the width is 20, and the length, which was 2x, is 40. And if we want to make sure that we're right, we can add them all up and see if it works. Of course, this is also 40, and this is also 20. And if we add them all up, does in fact that equal 120? Well, 40 plus 20 is 60, plus 40 is 100, plus 20 is 120. Yes, so we know that it works. This is the kind of problem that you're going to get and in order to apply this formula. So the formula is a very simple one to apply. All right, if something is a square or a rhombus, which means all four sides are the same, pretend that's a square, so your perimeter is simply 4 times any side, because all the sides are the same. So if this side is 8, what's our perimeter? Well, what's 8 times 4? Okay, 32 is absolutely correct. Very good. Okay, so that's 4 times a square rhombus. The perimeter is 4 times any side. Okay. A circle is a little bit more complex, and a circle is where we come into this concept of pi, which is a constant, it's a number, and it's approximately 3.14159, etc., etc., etc. Usually people just round it off to 3.14. It's also approximately 22 sevenths. Again, it's not exact, but it's close enough. If you put it in a calculator, it'll give you a more precise number. But anyway, the idea of pi is that the circumference of a circle, which is the same thing as saying the perimeter of a circle, is pi times the diameter of the circle. Or, which is also the same thing as we discussed last time as well, 2 pi times the radius of a circle. So if I have a circle, the distance from the center to any side, this is the radius. The distance from one side to another through the center, that is the diameter. And of course, the diameter, by definition, is always twice the radius. So, for example, if I tell you that a radius is 10 feet, so what is the circumference of a circle? Of this circle, what is the circumference? Well, if the radius is 10, then 2 times the radius is 20. 20 times pi. Now, in general problem-solving skills, you can just leave it in terms of pi. You can just say your answer is 20 pi. If you're asked for a more precise number, well, just take 20 and multiply it by 3.14. And 20 times 3.14 is, well, I'll do it on my, look, I probably shouldn't have to do it on my calculator now, but I don't want to get it wrong, so I'm just going to do it on my calculator. Assuming my calculator will actually work. And we've got 62.8. So our answer is approximately 62.8. It's going to be a little bit different than that, but that's close enough. So you can round it off to the nearest tenth or nearest hundredth, something like that. Okay, so that's the circumference of a circle. Now we're going to move to the areas. Areas are a little bit harder because they cover a little bit more ground. The formulas are a little bit more complex, but it's the same basic idea. Okay, so the area means the number of square units that the polygon covers. It could be any particular unit. It could be square feet. It could be square miles, square kilometers, square meters, square whatever. And you can envision by putting it on a graph covered by one boxes. You see that little graph over here in the lower left-hand corner? Without looking at it, without looking at the number that I put down next to it, it's fairly obvious how many boxes the red rectangle covers. If you want to just count it, you can count out boxes in there. If you didn't want to count it, how would you figure it out? Let's say I wanted to figure out the area of the red rectangle, and I didn't want to sit there and count the boxes. How do you figure out that it's 27? Exactly. The area of a quadrilateral, not any quadrilateral, but area of a rectangle, really just a rectangle. It doesn't work for other quadrilaterals. The area of a rectangle is the base times the height, or, which is the same thing as the length times the width. Just multiply it. Now, the red one on the slide, well, you can see it's 3 high. If you count, you can see it's 9 wide. So it's 9 times 3, and so the area is 27. That's a pretty simple one. So the area of a rectangle, base times height. The area, by the way, like I said before, of a parallelogram is not necessarily base times height. Whoops. Let me try to draw a parallelogram a little bit Well, can you pretend for me that's a parallelogram? Sorry, I know I'm making you stretch your imagination a little bit to consider that a parallelogram. But the area of this is actually going to be a little bit less than the base times height. So for example, if this is 6 and this is 10, the area of this is not 60. The area of this is actually going to be a little bit less than 60. If you try it, you can, if you do it on a diagram, you'll see why if you look at it, but basically it's not going to be the exact same. Well, actually, I'm sorry. It would be the base times height, but the 6 is not the height. You see, the 6, which represents is slanty, is diagonal. Certainly it would be the base times height, but the point is the 6 is not the height. If you would be able to tell me what the length of this dotted line is, then whatever the length of this dotted line is, that would be 10 times that, whatever that number would be, 10 times that would be the area. So really for all quadrilaterals, for all four-sided figures, if you got the length of the base and you got the length of the height, you would be able to figure out the area in that way. Now, what about a square? Can anybody tell me? I'm not even going to put up the slide here. Can anybody tell me what the area of a square is? This should be easy enough, right? The area of a square. Excuse me. Right, any side squared, because the sides are all the same. So if this is 5, well then it's 5 times 5, and the area of this is 25. So we have the area of this, by the way, this is a mistake over here. I'm sorry. A rhombus is actually just base times height. It's just a square that's a side squared. A rhombus would also be base times height. So for example, if you had a rhombus, which in other words have 4 sides but on different angles, it would not be any side squared. It would actually yeah, you'd have to do the base times whatever this is. You'd have to do a side times whatever that dotted line would be, which would be actually a little smaller. So really, the area of a square is a side squared, and the area of any other parallelogram is base times height. Which is not necessarily, in a rectangle, it is the sides multiplied by each other. In a rectangle, because it's a right angle on the corners over here, this is the base, and the sides are actually the height. But in other parallelograms, it doesn't work like that. Okay. So the point is, so that is how to figure it. Those are the formulas, and they're all fairly logical, hopefully, for figuring out the areas of a quadrilateral. A trapezoid, which remember is a quadrilateral with only one pair of parallel sides. Let's say you have something like this. Now this is parallel to this, but the other two sides are not parallel to each other. So this is a trapezoid. And so your area here is your average base times the height. Now the way to figure out, of course, the average base is a half of the first base plus the second base. See why that is? If this is 20 and this is 12, so what's the average base? Now you can look at it using this formula, or you can just figure it out in your head. What's the average of 20 and 12? 16. Good. How'd you figure that out? Well, just either you could just think, well, right in between 20 and 12 is 16, or add them up. 20 plus 12 is 32, and divide by 2, or take half of that, which is 16. So it's the area of the average base times the height. And of course, the height would not necessarily be the lengths of the sides. Instead, the height would be this dotted line, which would be coming down straight from the bottom to the top. Okay. So that is the area of a quadrilateral. How do you figure out the area of a rectangle? think about a rectangle as being almost a half of a quadrilateral. I mean, let's take a nice clean shape. You know, like maybe a rectangle, something like this. What happens if I split the rectangle by putting a line right here? Notice how I get two triangles? Triangle 1 and triangle 2. What is going to be the ratio of the area of the triangles as opposed to the rectangles? It's going to be half, right? The triangles combined equal the entire rectangle. So with that in mind, the area of a triangle is base times the height divided by 2. In other words, 1/2 of the base times height. Now, in a regular triangle, you can't always figure out automatically what the height is. The base is this thing down here, the cross beam down here. The height, on the other hand, just like we saw before, would be this line. This is what is called an altitude. An altitude is basically a line from the top to the base that forms a right angle that's perpendicular. The straightest line possible, in other words, the shortest line possible from the vertex, which is this point where the two lines meet up here, the two line segments meet up here, straight down towards the base at a right angle. So it might not be that easy to figure out the height. You may have to use other formulas that we're going to learn about later on in the course to figure out the height. But once you figure out the height, you can figure out the area of the triangle. So for example, if I tell you that this is 10, and this line, that's an altitude, that's a right angle over here, is 6. So who can tell me what the entire area of the whole triangle is? Applying this formula. Applying base times height divided by 2. 30 is correct. Very good. How'd you figure that out? Well, the base is 10. So we'll put that 10 over here, times the height, which is 6, and we'll divide by 2. 10 times 6 is 60, divided by 2 is 30. Okay. Now, we get to the circle. And the circle has a formula of the area that is a little bit more complex. And we're going to be doing a bunch of examples. As you can see, we're going through the slides relatively quickly, and then we're going to look at examples. The area of a circle, again, we have pi that we're dealing with, is pi times the radius squared. Whatever the radius is, square that, multiply by pi. So if I have a circle, and assume that this line this point in the middle is the center of the circle. Now, what if I told you that this entire line is 10? Based on that, can anybody tell me what the area of this circle is? Or you can tell me how you would go about figuring it out. Well, the area of the circle is pi r squared. Okay, not quite 100 pi. Good thinking, but you're both on the right track, but you missed one little point here. What's the radius of this circle? That's right. There you go. It's not 10 because 10 is the whole diameter. If 10 is the whole diameter, then the radius is actually 5. That's right. Exactly. So the radius is 5, which means the radius times 5, the radius times squared is 25, so it's actually 25 pi. And 25 pi is going to be about, 78 point something like that, approximately that. So that's how you would do that. First you have to figure out the radius. Now we've got this. Then the last kind of problem, we're going to do a bunch of these problems in a little while, but the last kind of problem I want to look at is a problem of the shaded region problem. See, one of them is on the homework, I think, question. How many shaded region questions do I have on the homework? One shaded region question on the homework. And a lot of the ones on the homework, by the way, are questions that ask you to kind of combine a couple of a couple of rules that we learned today. Just doing one of them is not going to be enough, and we'll see a couple of them. Yeah, we'll see. Excuse me. Okay, let's look at the shaded region problem that we have on the slide over here. Now, in this slide, you might not. Hopefully, it's big enough for you to be able to see. We have a square that is surrounding a circle, and the circle is light, and the external area outside the circle within the square is dark. And we need to find out what is the area of the shaded region. Very common type of problem you see on biology issues, and again, the sort of thing that you're going to have to deal with if you're a contractor, for example. Let's say I've got a backyard. I have to know how much grass seed to purchase. And in the backyard is a rectangular backyard, but it's got a circular above-ground swimming pool. Well, that's a classic shaded region problem. We're trying to figure out how much grass there is, which is the entire area of the backyard, subtracting whatever area is covered by the circular swimming pool. So think of that as this kind of a problem over here. So let's look at our example here. How do we do this? Well, number one, first step, we can figure out the area of the entire big area, and then we can subtract the area that's not shaded, which in this case is the circle. So let's try the outer area, which is the square, first. Let's assume that this is a... By the way, is this a square? Can anybody tell me, how do I know it's a square? Who can prove to me that the area on the slide, on that diagram over there, is a square? Again, not such an easy question. We didn't cover it directly, but who's thinking? Who's got your thinking cap on, so to speak? How do you know? How can you prove to me? Okay, but a rectangle can have 4 right angles too. Okay, Devorah, I think has it, and that's correct. If you think all sides of the square hit the end of the circle, notice how they all hit the end of the circle. Now, in a circle, the distance from the center to all ends have to be the same, and because all sides of the square hit the same circle, they all have to be the same because they all have to have the same diameter. So this has to be a square. What is each side of the square? Who can tell me what each side of the square is? Remember, the area of a square is any side squared. So what's the area of each side of the square? What's the length of each? 16, very good. Because the radius is 8, which means the diameter is 16. So going all the way across the circle, and therefore all the way across the square, is 16. And so it's 16 squared. 16 squared is 256. So the area of the square is 256. Okay, now let's figure out the area of the circle. What's the area of the circle? Pi r squared. What's the radius? Okay, the radius is 8, right? So 8 times 8 is 64 pi. And 64 pi, I guess Gina says, is 201.6. I trust you completely, but I'm going to do it on my little calculator anyway. Hope you don't mind. And it is, I have 296. Pretty close, but okay. But, well... unless your calculator might have actually done the pi, I rounded it off to 3.14. So if your calculator did did pi itself, yeah, it's going to be slightly more. Okay, that's right. Actually, yeah. So if you do it, if your calculator actually, some calculators actually have a pi button where you can press it in and it gives you pi to something like 8 or 9 places. Right. Okay. So the area is 201.06 approximately. So what's the area of the shaded region? How do we figure that out? Okay, subtract. Take the 256 and subtract the 201, which in this case is 94, 54.94. The Common Core wants you to do it differently. I was looking at my kids' math homework. I remember, of course, when I was a kid, so you can't take 6 from 0. So I made that into 100 and borrowed 1 from the 6 and made that into 94. So took the 5 minus 1 is 4, 5 minus 0, and away you go. That's the way I did it in my head. The Common Core, they have this whole crazy way. I honestly couldn't figure out how to do my 7-year-old's homework. They don't want you to subtract. They want you to take the hundreds column and put that in one side, and then I don't know. They have this whole crazy thing. I'm just gonna do it the old way. I hope nobody minds if I'm not following the Common Core. I'm just gonna take. Well, you can't take 6 from 0, so you borrow it from the six column. All right, all right. So I don't know. I was gonna tell myself. I was thinking of telling myself, just do it this way. Just do it my way. But um, although although when our way was first thought of back in the 60s, the our parents or grandparents who were studying back then also were confused by this new way, the way that we learned. In fact, there's a song that was written in 1965 by Tom Lehrer called New Math. If you want to Google, you go to YouTube after class or something and watch the New Math by Tom Lehrer. He goes through this our way as being this newfangled, complicated way of doing things. So I guess that's the way it always goes. Yeah, listen, I guess there must be a reason behind the Common Core, but I think what they're trying to do is get the kids to understand that the hundreds column really means 200. When I was a kid, maybe I didn't really fully understand that in the third column that 2 really meant 200. So I think now the Common Core is trying to really ingrain to the kids that 2 doesn't mean just a 2. That 2 means a 200. But anyway, so I think that's the logic behind it. All right, so that's that kind of a problem. Okay. Now what I want to do is I want to look at problems that are a little bit more complex, and for that we're going to do a little bit of screen sharing. Okay. Okay, can everybody see my Microsoft Paint over here with this really scary looking problem in the middle over there? Okay? Okay. Our job, should we choose to accept it, is to figure out the area of the blue region. Anybody think we can do it? Who has confidence in all of us that we can figure out the area of the blue region? Okay? All right. Looks pretty complicated, right? But not too bad. So let's think about this from a strategic perspective. How do you think we should first figure out what's our first step to figure out the area of the blue region? Let me make this a little bit thinner. All right. Okay, good. First thing is I would take the whole area, including this white area. See, I can just undo that. And this area. So I can just undo that. How do I figure that out? How do I figure out, in fact, I'll put the whole thing, I'll make the whole thing in blue. Our whole first step. How do we figure out the area of the whole thing? Well, well, what shape is it? What shape is the whole thing? It's a rectangle, right. So the area of the rectangle is 40 times 25. Well, 40 times 25 should be, it looks to me like 1,000, right? Because 4 times 25 is 100, so 40 times 25 should be 1,000. So we've got 1,000 for the entire thing. Now I have to subtract each of the 2 smaller shapes over here. Okay. What is the area of this over here, this rectangle here? How do we figure that out? Well, this is also a rectangle, right? So the area is 14 times 12. And 14 times 12, of course, would be 168. Okay. What's our 60? Yeah, okay, 168. And what's our third thing over here? Our third thing What shape is that? Oh, no problem. So what's so the way I was just thinking about, because 12 times 12 is 144, so then you got two 12s left. So two 12s plus 144 is 24, which is 168. Okay, anyway, so fine. So yeah, so we've got a triangle. Triangle. What's the area of a triangle? Area of a triangle is base times height divided by 2. What's the base of the triangle? Sideways, but you can still look at it as though we're... Okay, good. The base is 25. What's the height of the triangle? 10. Okay, divided by 2. So 25 times 10 is 250. Divided by 2 equals 125. So our entire blue region is 1,000 minus 168 minus 125. Now, I hope nobody minds. I am going to do this out the old way on principle, and so I am going to make this into a 10, and this into a 9, and this into a 9, and eliminate this. So I've got, well, I can't do that because I'm going to do it one step at a time. I hope nobody minds. All right. All right. And we've got, okay, and now we've got 832. I don't know why I'm not doing this in my head. I should, but all right. All right. We have 707 altogether. Okay. So our area of the entire blue region is 707. We just took the whole area and subtracted smaller ones. All right. Let's go back. I've got some more that we can look at a little bit later on. But let's look at the homework and see if we can. Did my Snagit finish installing? Yeah. Okay. So, all right. Snagit's gonna have to. Okay. 1 second. Okay. Let me get over here for this problem here. Find the area of the shaded figure. Assume the curves are semicircles. Round your answer to the nearest 100. Okay. 1 second. I just have to open Snagit so that I can get this. Oh, it wants me to sign in? Oh, 1 second. All right, never mind. I'm sorry. I'm not going to be able to. I'm not going to be able to do this. We're going to have to. I'm going to have to do this side by side with Paint. I'm sorry. I just installed it on this new computer. Okay. Okay. So what we have over here, we've got two semicircles. Now, how would we go about? Right. Okay. So from a strategy perspective, how would we go about doing this? Notice that there are two semicircles here. What do two semicircles get you? One full circle, right? So the strategy I would use if I'm looking at this is I would take the area of the whole rectangle. What's the area of the whole rectangle? How would I figure out the area of the whole rectangle here? Okay, I would just multiply it. Multiply the base times the height. The base and height are given to you. The base is given to you as 14.2. The height is given to you as 6.8. Now, if you to imagine the two semicircles combined, that would be one full circle. How about the area of the full circle? Well, the area of the first full circle, like any other circle, the area is pi r squared. What's the radius of the circle? What's the radius of each semicircle? 3.4, very good. So what you would need to do is do pi times 3.4 squared. And 3.4 squared is 11.56, 11.56 pi. So essentially what you would need to do is you would need to take the entire rectangle area and subtract 11.56 pi. What if there were only one semicircle? In other words, what if this whole area were dark? What if I blackened out this whole area over here? Then how would we adjust our strategy? Yeah, exactly. Just divide by 2. Just divide by 2 in order to figure out what the area was. I would still take the same formula. Still take 3.4 times 3.4 times pi, which is 11.56 pi, which is approximately 34, 35, something like that, and divide it in 2, and you get about 17 or so. And still subtract it from the entire area. Okay. Number 5, you're not going to be able to do. Okay, the number. Okay, so some of these you're not going to be able to do until after class 5. For example, after class 4. Number 5, you're probably not going to be able to do until after class 4. How would we go about doing number 3? I think number 4. Again, I don't want to do these for you. Obviously, I don't want to ruin your fun. But can you? Who wants to at least think of a strategy for doing number 4? Kind of a strategy. We want the surface area of the rectangular prism of the box. Okay, we've got a picture here. This is number 4. Number 4, we have a picture here. So how many edges are there? How many surface area edges are there on a prism? 6. That's right. So really what you need to do is you need to add up the area of all 6 of them. There are 6 sides. There's the front side over here. There's the back side over here. There's the bottom. There's the left side. There's the right side, and there's the top. So there's 6 altogether. There's 6 altogether. And notice there are really 4 rectangles and 2 squares. The front edge and the back edge are squares, and the others are all essentially equal rectangles to each other. What's the area of the rectangles? All 4 of them? All 4 rectangles are the same. It's a rectangular prism, which means by definition it's rectangular, which means all four are the same. So how would I figure out the area of the 4 rectangles? Multiply the base times the height. Multiply 9.1 times 13.5. And again, common sense, how would I figure out the area of the squares? 9.1 times 9.1. And then just add them all up. Number 3, by the way, is a is a shaded region problem. You try number 3 by yourselves. I think number 3, you draw it basically. Draw a rectangular lawn, 10 by 25. Draw a. You can use a straight edge. Use a. Let me draw it. Where's my Microsoft Paint? There it is. Okay. And if I wanted to draw a, I don't have. Well, I know you can't see it now, but it says a sprinkler is set in the corner of a rectangular lawn 10 by 25 feet, and the maximum distance a sprinkler can reach is 10 feet. So if you drew a rectangle, I actually let you do that. Let's say 10 by 25, like this. And then you'd have to draw a circle. The sprinkler set in the corner, I'm sorry. The sprinkler set in the corner of a rectangular lawn that's 10 by 25. So the circle would start over here and have a radius of what? The sprinkler is set in the corner. Let's put this down here. Okay, there we go. We can do it like this. Okay. So a sprinkler is set in the corner by 10 by 25. So this is 10. Let me just write this. I'm sorry, this is 25. And this is 10. Okay, so what should we do with the circle? What should we do with the sprinkler? Where should we put the sprinkler? It's a little bit of thought. What do you think? Anybody have a suggestion about what to do with the sprinkler? Well, we got to put it in the corner. Doesn't matter which one, by the way. Doesn't matter which corner. And the maximum it can reach is 10 feet. So what kind of a shape is it going to be? It's going to be a circle. Because a sprinkler, by definition, if you think about anything that can only reach a certain distance from one point is a circle with a 10-foot radius, exactly. Yeah. Anybody remember locus? When, like in high school math, they teach you a little bit about locus, L-O-U-C-U-S. So the locus of points that are equidistant from a particular point is a circle. If I, for example, if I'm sitting right here, and my car can go 200 miles in any direction. So if I wanted to draw you on a map where I could possibly go, it would be a circle with me in the center and a 200-mile radius. So the radius from a corner. Let's see this circle tool here. I don't know if you can do this so easily. So let me use a different color. Now this is a line. Is there any way to get this to draw a semicircle? Well, maybe I can start from up here. Yeah, okay, that looks pretty good. Actually doesn't really look much like a circle, but all right, let's pretend this is a circle. It's not that far off. It's not outside the scope of the imagination. All right. So this, of course, this line is 10, of course, by definition. And notice I had it land on the corner on purpose because this is 10. How far is this distance? From here to the orange edge of the circle? Of course, it also has to be 10. So what would be our strategy to figuring out? Okay, so how much lawn it could cover? So I'm sorry. What were we asked over here? We were asked what percent of the lawn? It's a good question. What percent of the lawn will be watered from this position? Well, how do we figure that out? First, we would have to figure out the area of the entire yard. That's easy. That's a joke. Who can tell me the area of the entire yard? Just 25 times 10, 250, right. So, but to figure out the area covered by the sprinkler, it would really be a quarter of the circle, because only a quarter of the circle, it's really kind of a waste, it's kind of a stupid thing to do, to put your sprinkler all the way in the corner of the yard. Only 1/4 of the sprinkler's effectiveness is actually going onto the yard. But all right, listen, you can't ask questions on a problem like this. So take a quarter of a circle. So figure out the area of the circle, and the area of the circle is pi r squared, and take 1/4 of that. And then take your result. Once you have the result, what do you do? Once you have the area of this whole area over here, then what do you do? Not subtract. Remember, you're not asking for the area. We're asking the percentage. We're asking essentially what the question is asking is what percentage of the entire thing is orange. So you get to divide. That's right. And dividing will get you the percentage. All right, very good. Okay, let's take some of these problems here. These aren't in the homework, but and if you look at the rest of the homework, whoops, where did the homework go? There it is. All right, number 1 is about perimeters. That should be fairly simple. Number 4 we discussed. 3 we discussed. 5 you can't really do yet. 6 we didn't really discuss yet. Okay, so really from 1 through 4 you should be able to do after today's class, and 5 on is probably you can do. You could probably do number 9 now anyway, but okay, then we can do after class 4. All right, so let's take a look at some of these problems over here. How about this one? This looks like a good problem. This looks pretty complicated. Let's do it. I like complicated problems. All right. Okay, we're not going to prove anything. So let's say let's give ourselves the following. Forget E and F and G for the time being. For our purposes, let's say given B is the center of the largest circle, and we'll also say that the area of circle C is, let's say, 100 pi. I don't know how to get the pi symbol. The area of circle D, excuse me, is 25 pi, or let's say, let's make it 16 pi. And find the light blue, find the area of the light blue region. That looks like a pretty good one. Who thinks they could do this? B is the center of the largest circle. The area of circle C is 100 pi. The area of circle D is 16 pi. Find the area of the light blue region. Okay, let's do this. This is fun. Anybody agree? Anybody disagree? Whatever. All right, doesn't matter. We're doing it anyway, fun or not. Okay. All right, let's try this. What's our strategy here? What's our strategy to try to get the blue region? Okay? We need well, okay, but let's take it one step at a time. You might very well be right about that, but let's take it one step at a time. Okay, the first thing is we obviously want to find the area of the entire circle, and then we could subtract the this circle over here, and then we can subtract this circle over here, and then we can subtract this circle over here, and essentially we could take half of whatever's we could really take half of that, really subtract half of all the circles, because half of it is not there anyway. Now, the first thing we really need to do, though, is to figure out in order to figure out the area of the entire circle, in order to figure out the areas of the, let's say, of this circle here, we're going to need to find the radii. So let's try to find the radii of each of these little circles. Circle D. The area of circle D is 16 pi. What does that tell us about the radius of circle D? Well, remember, the area is pi r squared. So the area of circle D is what? If it's 16 pi, 16 is what squared? Not 8. 8 squared is actually 64. It's 4 squared, right? Okay. So that means the radius of circle D is 4. That's the radius of circle D. What's the radius of circle C? based on the fact that circle C is 100 pi. The area of circle C is 100 pi. So what's the radius of circle C? The middle, the middle size circle over here. Who can tell me that? Well, if the whole thing is 100 pi, it has to be pi r squared. Well, what squared gets you 100? 10. Okay. So the radius of this circle is 10. Now, if the radius of this circle is 10, so what's the diameter? What's this whole length over here? What's the diameter going all the way across from here to here? 20. Good. And what about the diameter of the small circle? What about the diameter of D? 8. That's right, because the radius is 1/2 of the diameter. So now, if this is 28, well then what's this? What's AB? How big is AB? Also 28. How do you know that? Because I knew that B is the center of the circle, largest circle, and if B is the center of the circle, then all radii are the same. BD is a radius, and therefore BA is also a radius, and the whole thing is 28. Okay, great. So now, what information does that give us? Can that be the area of the entire circle? The answer is yes. It can give us the area of the whole circle. The whole circle is, again, the area is pi r squared, which is pi times 28 squared. What's 28 squared? 700 and something? 1 second. 784, okay. Right, so 28 squared is 784. Okay, so it's 784 times pi. Okay, 784 times 3.14159 is, yeah, 2463. Perfect. Okay, so the whole area is 2463. We're rounding it off a little, but that's fine. All right, so now that we've got the whole area is 2463, now what? We're not quite finished yet. We still have some things to work through. Anybody have any suggestions of what we can do? There are really 3 or 4 different ways you can go about doing this. There's no one particular right answer here. Okay. Number one, so we can get all the smaller. We can get the areas, the smaller circles. So, what's the area of the AB circle? The area of the AB circle is what is the radius of the AB circle? Well, the area of the radius of the AB circle is of course 14. Good. So it's 14 times 14. 14 times 14 is 196, and 196 times 3.14159 is 615. We'll round it off 615.8. Okay. What's the area of this circle, of the C circle? Well, that is, what's the radius? Radius 10. So it's 100 times pi. Well, we already told it was 100 times pi. So good. So we'll round it off to 314.15. So we'll round it up to 314.2 since we're rounding everything off to the nearest tenth. And this, the area here, is 16 pi. What's 16 pi? Well, is 50.3. We'll round it off to. Okay, good. 50.3. Okay, so one thing we can do is we can take the whole area and subtract the areas of the little ones. So we're going to subtract 615.8, subtract 314.2 and subtract 50.3. And that will give us, well, this one we got to do, this one I'm going to just do my calculator here. 2463 minus 615.8 minus 314.2 minus 50.3 is 1482.7. That's right. That's what I got as well. 1482.7. Is that our final answer? No, that's right. We got to divide it by 2. That's right. Very good. That would be our answer if the blue stuff included all this. It doesn't include all this. It only includes half of that. So let's divide by 2. And we've got 741. And I'll keep rounding it off to the nearest tenth, because that's what we've been doing until now. So we've got 741.1. So 741.4. And that's the area of the blue region. So, again, all these things, it's a matter of thinking about it, coming up with a strategy, and away you go. And that's about all the time we have for today. Wednesday is Veterans Day. I'm not sure. You know, I kind of like gave every teacher the option to cancel class if they wanted. Some have, some have not. It's really up to them. I really can do anything. I mean, I don't mind doing a class on Wednesday. If you'd rather have off, I don't mind doing that also. What do you think? Let's take a little vote of the people who are here. Yeah, the school offices will be open. But, you know, if we give off Veterans Day, so we'll just make it up in future classes. I'm not going to, you know, schedule another class. Well, I think we can make it up by catching up, like going a little faster in future classes, or we can just have class on Wednesday. Okay. All right. Okay. So let's have a class. Okay. So let's have class Wednesday. Okay. Good. So we'll do that. No problem. I will see you then, and we will be discussing the end of chapter 3 in the textbook. We'll be doing the Pythagorean theorem, which is, of course, a critical component of geometry, and then we will be doing surface area and volume problems. Okay, great. So fantastic. So I'll see you then, and have a wonderful day, everybody. And volume problems. Okay, great. So fantastic. So I'll see you then, and have a wonderful day, everybody.